Good morning, student. How are you all? Okay, fine. And I hope that we have completed some topics. All you are making the notes. Okay, and now we will discuss the related that chapters. That means the magnetic effect of current and magnetics we have started, as you know that, and many topics we have discussed. Okay, now today we will discuss the important topics, that is the Ampere circuital law. Ampere circuital law. Okay, this is the Ampere circuital law. Ampere circuital law means what? When you know that the magnetic fields through a closed circuits, okay, that is equal to, what is equivalent? Equivalent, you know that the mu naught times the total currents. Yes, very good. So you can write their definitions and we will also prove their statements. But before it, okay, please like my channels, subscribe, and when the class will over, and please share my video in any groups. Okay, now come to the points. We can write their definitions of Ampere circuital law. Anybody, can you say what is the statements or definitions of Ampere circuital law? Okay, you can write. It states that the line integral of magnetic fields line integrals of magnetic field, okay, around any closed path or circuit is mu naught is equal to what? Is equal, okay, equal to mu naught times the total current threading. Okay, through the closed circuit, okay, or closed path. That means the closed integrals B dot dl is equal to mu naught I. Okay, according to Ampere circuital law, it states that whenever the current will passes through the conductors, as we know that due to flow of the current, it changes in the magnetic fields, and that is equivalent B dot dl is equal to mu naught times the total current through that closed circuits or closed path. Is it clear? Now you can prove these ones. Okay, you will prove the Ampere circuital law. It means to prove Ampere circuital law for closed path. Okay, for closed path means you will take the closed path, and during which you will see that whatever the magnetic fields will produce, and that will equivalent, okay, mu naught times the total current. Just like you take, suppose that you have your conductors, you can assume, suppose that X and this is the Y and I current flowing through these ones. Okay, and suppose that this is the points P. P is the point where the magnetic fields can be observed. Is it clear? Okay, very good. And you can take the elementary portions. Suppose that this is the point P and this is the magnetic fields, and this is the Q, and this a small is, that is the DL. Okay, elementary portion, this is DL, and r is the radius of the circular path that you can take here. Okay, this is the diagram. Now whenever the current will passes, you can consider that the current is flowing from x to y. Okay, I current is flowing, due to which the magnetic fields will produced. Okay, so magnetic fields, that means B dot dl will mu naught I, that you have to prove. Okay, but you can assume what is here, let I is equal to current flowing through x to y. Next, dl equal to a small or elementary or a small portion or length. Okay, portion or length also you can write. R is equal to radius, vector B is equal to magnetic field. Is it clear? So you can write these ones. Now as you know that these positions, if you will take according to their statements, we have closed integral B dot dl. What you will write, B dot dl you can write here. If you will remove, then here will be closed integral B dl and then cos theta, and theta is equal to 0. Okay, so theta 0, so cos 0, what is the value? Cos 0 equal to 1. Okay, very good. So close integrals B dl into 1. Okay, or you can write this one, means what you will write, close integral vector B dot dl is equal to B, you can write outsides, and here will close integrals dl. What is the value of dl? dl you know that's, okay, dl equal to B into, this is the 2 pi r. Okay, 2 pi r, and since B is equal to mu naught by 4 pi into 2I by r, this is the value of B. Okay, so this value you can substitute. So therefore you can write close integral B dot dl equal to, this value you can substitute here. If you will substitute, so here will be mu naught by 4 pi into 2I by r into 2 pi r. I think that some terms will cancel out. Which you will cancel out? This r and r will cancel out. Pi and pi you can cancel out. And these 2 and these 2 2s are 4, and this will be cancelled out. Finally you have B dot vector dl is equal to mu naught, and here is the, this is the currents. Okay, so I mu naught I. Okay, so you can write, you see that statements we prove here. This is the, okay, proved. Is it clear? Okay, what is the value of mu naught? Mu naught is equal to 10 to the power minus 7 into 4 Tesla meters per amperes. Okay, you should remember why, because already we have discussed mu naught by 4 pi is equal to 10 to the power minus 7 Tesla meters per ampere. You can cross multiply, so you will get the mu naught value. Is it clear? So this is the statements of Ampere circuital law, and we have also proved there's this statement, that is a B dot dl is equal to mu naught I. That formula we got. It means we have questions to prove Ampere circuital law for closed path. Whenever you will take the closed path, for that we got the value B dot dl is equal to mu naught I. Is it clear? So already you know that there is one more case that you have to prove, that is the for arbitrary. Okay, in case of the arbitrary you can take, and that will also we will discuss in the next class. Okay students, and you should write this question, that's very important for all boards. Okay, not only the boards, events, and those who are preparing for the advanced mains and other competition exams related this, okay, formula you will use, and so many questions you will solve with the help of this Ampere circuital law. Basically for the IIT students, I think that they should see these ones. You know, this is the formula that you will also prove whenever we will start the applications. Yes, applications after completing the arbitrary, we will also complete that ones. Okay, till now, those who have not subscribed, please subscribe students, and share this video. Okay student, thank you.